Errors in cell division can change the chromosome number and result in new phenotypes. So we talk about nondisjunction, and nondisjunction can happen at different places in metaphase within meiosis 1 or meiosis 2. And ultimately that can result in differential numbers of chromosomes. So through fertilization, we can have monosomy or trisomy, where they should be diploid. So we have these numerical abnormalities that can occur, and if we have monosomy, it means that we're missing one. All the rest of these chromosomes in this karyotype are diploid. However, this is showing that there's a missing X, and this is Turner syndrome. And when you change the karyotype, you're going to change the phenotype. So women with Turner syndrome are going to have this low posterior hairline. They're going to be shorter. They're going to have a webbed neck. They'd have a small aorta, broad chest, extra moles, and they might have, or they're going to have changes in their ovaries. So a lot of times that's going to lead to infertility. So we also have where we can have too many chromosomes, and this is a karyotype where there's 321, so that's trisomy, and that's Down syndrome. And I think because it's more common, most people are familiar with that. But again, the change in the number of chromosomes ultimately affects which genes are expressed and what amounts. So that can lead to an increased tendency towards leukemia, cataracts, accelerated rate of aging, besides the typical phenotype that you see. And again, it comes down to this expression of genes. For example, this GART gene being overexpressed, that leads to some of the intellectual disabilities that are also associated with Down syndrome. So again, most of the time we think about things being diploid, and then their gametes being haploid. During fertilization, they get brought back to diploid. However, there are some things that naturally exist with different ploidy, like tetraploid. So for every chromosome, there's not just one backup, there are 3 backups. So blackberries, peanuts are tetraploid. We can also have triploid or triploid. And these triploid, a lot of times we think about seedless watermelons and bananas. Hexaploid, again, hex is 6, so there's 6 chromosomes backups for each individual chromosome that exists with wheat and sweet potato. And we can even have octaploid, where there's 7 chromosomes, but there's 8 copies of those. So a lot of our strawberries that we deal with have 8 sets of 8 chromosomes. So again, our wild strawberries will be diploid. There are some wild strawberries that are tetraploid. But again, sometimes this ploidy within plants can lead to increased vigor. So as we have this polyploid fruit, it's going to grow a little bit greater, and the fruit that it produces might be a little bit larger. And again, sometimes we see that in extreme varieties. Now again, when we start thinking about this, sometimes these things happen naturally, and sometimes they've been cultivated and bred for. So a diploid banana is going to have seeds, and I don't think most people have ever seen a banana with hard seeds in it. So we have these triploid bananas which have no seeds. Well, if they have no seeds, how do they reproduce? So you can cross diploid and tetraploid, sometimes to get triploid. However, a lot of times in the banana industry, you have a triploid banana that's making seedless fruit, and what they end up doing is they take off these suckers, these extra growths, and they can replant the suckers, which grow into full banana trees. There's other ways that you can take pieces of the rhizome and take cuttings and also regrow the plant. But again, without having seeds, we can't reproduce. So when we start thinking about reproduction, we're going to have to tie in these evolutionary implications to differences in the and having atypical phenotypes. So when we think about this, whatever is favored in the phenotype will get passed on through the genotype. But when we think about survival of the fittest, they have to survive, but they also have to reproduce. So when we think about some of these non-disjunction disorders, like Edwards, where there's 3 18s, or Patau syndrome, where there's 3 13s, the chance of surviving to their first birthday is less than 5%. So they aren't going to be surviving. And then other disorders typically are associated with infertility, so they can't reproduce and pass that on. And when we think about infertility, these bananas are also going to be infertile, which then artificial selection has to be brought about, and it's something we want, so then humans have to work around the evolutionary system to propagate them. Now, when we start thinking about wild polyploid strawberries, and this being an advantage to having bigger fruit, usually we think of bigger fruit as because we want to grow more. However, in the wild, an herbivore would be more attracted to the bigger fruit. Well, be like, is that a good thing if they're getting eaten more by herbivores? In this case, eating the fruit is an evolutionary adaptation, because if they're eating these seeds, which are polyploid as opposed to the diploid plant seeds, they're going to ultimately improve seed dispersal and put those seeds through their feces in more locations to further propagate the polyploid varieties. So again, we can have changes in the chromosome number which lead to new phenotypes.